Hello everyone. As part of learning big data with Hadoop and Spark, so far we have seen the concepts of integrity, how do we maintain data integrity, how do we go for compression, and we have also seen what are serialization and deserialization with respect to Hadoop objects. Now we will talk about what exactly are serialization frameworks, right? Serialization frameworks. MapReduce generally deals with key value pairs which can be of any type, and generally we work with writables because that is built in, we can easily work with that. MapReduce does not stop there, it will not mandate you to work always with writable, you can go for any type of objects. For this Hadoop comes with an API which is easily pluggable serialization frameworks, and it is an implementation of both serialization as well as deserialization. For example, writable serialization is one of the implementation for writable types. And every time whenever we work with the serialization, it defines a mapping between a normal object type to serializer instances, and deserializer talks about a mapping between the deserializer instance to a respective object type. And whenever we want to work with various types of serialization frameworks, in the configuration file we have a property called io.serializations. In that property you specify a comma separated list of all the classes which have a serialization implementation and which you would like to use. Say for example, I want to work with byte writables, and I want to work with null writable, I want to work with text writable. In the io.serialization property, you list out all these three with a comma separation. Then we will talk about something called as file based data structures. What do we mean by this? For some applications, we need a specialized data structure to hold my data. See, we are working with big data, the file sizes will be huge, and particularly some of the times the object size might be very huge. So, if the normal data plus this large object, together the file size grows enormously. So, in order to support to keep these blobs, binary large objects, we have specific type of containers or various types of file structures. Not only text files, not only .dat files, we have specialized containers in order to hold the binary large object, which in short we call as blob, right. Now, one such container is sequence file. Generally whenever you talk about sequence file, we can take an example of log records. What has happened since logging into the system, what activities a user has done, how did he do the manipulations, or what kind of data did he or she access. Generally whenever we share our data in Google Drive also, you have the log history. So, such kind of things can be maintained in a sequence file. For such things, plain text file may not be suitable, so we go for Hadoop's sequence file. So, I will just show you a sample example of the sequence file in my next slide. To create a sequence file, we can use the sequence file object is there. In that you have a method called create writer, and which gives you an instance of sequence file dot writer instance, using which you can start writing data into the sequence file. Similarly, I want to read data from the file, you have an instance of sequence file dot reader, which comes with the built-in method called as next, keeps on giving you the next records which are stored in the file. And Hadoop file system has a command hyphen text option is there, we call it as a switch in the command. Hyphen text option is there, which will display the sequence file content in text format. Otherwise you will see some special characters in the sequence file, but if you want to see the text content of that, whenever you are trying to show the content of a file, you have a switch option in that, wherein you specify hyphen text, which will show you the file in the textual format. And most powerful way of sorting one or more sequence files is we have to work with MapReduce. And MapReduce, we know it supports parallel processing as well as distributed processing. You can also specify how many number of reducers I want. Say for example, I want to find out how many people worked with my file in January and how many people have logged into my specific folder and they have done some activities during February. I want to find out the logs month wise. So, how many outputs do I expect in a calendar year? Maybe 12 outputs. For every output you are expecting, you can specify a reducer. So, likewise you can specify how many number of reducers you want to have depending on how many number of output partitions you are expecting. Then sequence file header consists of the following things. I will just show you that. So, this is how the sequence file header looks like. It will have the version number, sequence number, 3-byte sequence number will be there, and what is the key class name. What do I mean by key class name? As we have learnt, MapReduce files or MapReduce always deals with key value pairs. So, what type of object is the key and what type of object is the value. Say for example, I am working with student number is the key and what is its value, right. So, student number, that column header may be the key and what is the roll number value actually I am trying to store there will be the value. So, what is the key class name, which object are we using in order to represent the key and what is the object type in order to store the value. Then is it compressed file or a normal file? That value is indicated with a boolean type, yes or no. I have used a compression technique already in order to store the file. The boolean value will be set as true or yes. And block compression, whenever you talk about compression, there are two types of compression: record level compression, block level compression. What do I mean by this? For a single roll number, say for example, I am storing the marks in single subject. So, for every student how many values will be there? One roll number, marks in one particular subject. So, corresponding to a student there will be only a single record. On the other hand, suppose for every student I am storing the marks in 10 to 15 subjects. So, in such case for one roll number there will be a block of records. Am I compressing at record level or am I compressing at block level? What are you trying to do there? So, that will be specified again with a boolean parameter. Is it a block compressed file? Yes or no. The moment it is no, it is understood it is record level if this value is also true, right. If this is also false, this is also false, the file is not at all compressed. Then if at all any one of them is true, suppose record level compression has happened or block level compression has happened, which compression algorithm did we use and which decoding algorithm should I use? So, codec, coding, compression coding algorithm and decoding algorithm, that class name should be specified, and any other metadata, and this sync marker. This sync marker will tell us if at all we are going at record level, where does the record begin, where does the record end. If we are going at block level, where does the block begin, where does the block end. We are going to specify the sync markers. So, this will be the file header in every sequence file. So, if you see, this is how you will try to store the records, header, and for every record what are we trying to maintain? Record length, what is key length in bytes, what is the actual key you are maintaining, what is the value for that key. So, this is how we try to maintain a record, and if you see this format, in this format they are using a sync marker after every 2 records. So, they have tried to group 2 records and a sync marker is placed there, beginning of 2 records, end of 2 records likewise. Now, if you see this one, what did we try to maintain here? Again, record length, key length, key value and compressed value. What is the difference between these two? This is an uncompressed file, this is compressed file. I have used compression technique. So, which value are we placing here? Compressed value. An uncompressed file, you directly place the value. Now, what did we use in this? It is a block compression. I tried to put a group of records and I tried to store it in the file. If you see, sync markers are there for every block. And what did we store in the block? How many number of records are kept in a block? Compressed key lengths, compressed keys, value lengths, and what are the values corresponding to each key. So, this we call as a group of records have been compressed together, we call it as block level compression. Now, sequence file, generally with and without compression, this looks like this. The same diagram I have shown with this. Now, if you just identify sequence file, I have shown the header will be like this. Entire information will be maintained in this header. In the diagram, I am just showing it as header. What exactly are the contents of the header? All these things will be there in the header. Then, just a sample sequence file I am trying to show. If you see, this will have all the header information. If you identify this file, they are using this compression algorithm, right? So, this is actually how a sequence file looks. This consists of completely binary information and which stores log records. And apart from sequence file, we also have another data structure or a container for storing our data. We call it as the map file. It is a sorted sequence file and it also has index values which will help us to look up. And index is a sequence file which contains a fraction of keys. Every 128th key is the default value in order to store in a map file. And it offers a similar interface just like a sequence file for reading and writing and for performing read and write operations. What we need to do is that the main thing to be aware of is that when writing using map file.writer, whenever we are calling this method, map entries must be added in order. Otherwise, IO exception will be thrown because map files they go for sorted order. If we don't put the data in proper order, it will throw IO exception. Then map file variants, there are various types of map files are there depending on whether we are using sorted order. In such case, if the key values are stored in sorted order, we go for something called as set file. Otherwise, if the key is an integer which is representing index of the record location, we go for array file. And if the file comes with a Bloom filter which will help me to look up for whether a record is existing or not, we call such files as Bloom map file. Then column oriented files, so far when we learnt Oracle also, the data is row oriented. How do we define Oracle relation? It is a collection of rows. What does a row represent in Oracle? It represents all the details of a specific object. Say for example, I took student file. What will be there in the row? Row is the horizontal component of a relation. What will be there in the row? Student number, student name, marks in 3 subjects, which branch he or she belongs to, all this data will be there. So, if I take one single row, what does it tell? It tells all the details of one single student, isn't it? There is another format for storing the data. We call such kind of files as column oriented data, wherein data belonging to one particular person or one particular object will be maintained in columns, not in rows. We call such files as column oriented files. I will just show you an example. consider this data, right? So say for example, I have the data belonging to one particular person or student. Just consider 1, 2, 3 belongs to one object, 4, 5, 6 belongs to another object. So I have data about 4 objects. Consider this will be the normal row oriented files which we are habituated to work in Oracle and all. This is how we see the data. If suppose these are 4 students, student number, student name, which course he is doing, right. So if you consider that, we call this representation as row oriented data file. When you go for splitting the rows, how many rows do you get? Row 1, row 2, row 3, row 4. So my data is split into 4 rows. The same thing if I go for column oriented representation and I am breaking it 2 records, right. See the thing, I am going for column representation and at every 2 records I am trying to break my file or split my file. If you see, you are going by column and at every 2 records you are having a split. Which 2 items will come in the column? 1 and 4. So I will represent them like this. Then next which 2 will come? 2 and 5 for the first split. Then who are there? 3, 6. So this entire thing becomes your first split. Then who is there in the second one? 7, 10, 8, 11, 9, 12. These are the second split. This is how the column oriented files will be maintained, and regularly we are having row oriented files also. So column oriented file, the description is there, what type of frameworks are supporting and who is using what type of files. So I have just put all the things. For example, if you see Parquet, which we will see very soon, Parquet is a general purpose column oriented file format, and Google's Dremel is also using this, and Hadoop components Avro has column oriented files, we call it as Trevny. So these are various things who are supporting sequence files, map files, row oriented files, column oriented files. So if someone asks you what are various file oriented data structures, you may need to talk about all these types, right? Thank you.